All right, 4.6 is a pretty long section. It's about rank of a matrix and it's about systems of linear equations. So let's look at this. Rank of a matrix. Before we can define rank, we need to talk about the row space and the column space of a matrix. The row space of a matrix is the subspace spanned by the row vectors, and the column space is the subspace spanned by the column vectors. So let's look at this example right here. I don't have any instructions on it. I just want to talk about this matrix. This thing, its row space is going to be a subspace of R4 because each row has 4 elements, and if you start taking linear combinations of these 2 rows, you're going to get elements out of R4. Its column space is a subspace of R2. And if we were to look at this one and think about it, the column space of R2 is actually going to be, it's actually going to be of all of R2. So the column space of A is all of R2 because we can look at it and tell, we've got at least 2 vectors here that are not parallel to each other. So if you were to graph all of those in R2, you got 4, 2, which is, let's see, over 4, up 2. Then you've got 1, 2, which is over 1 and up 2. Like that. And once you've got those 2, that's enough to span the whole plane. So the column space is all of R2. The row space, I think, would, the row space would just be a plane within R4. Because if you look at these 2 vectors here, 4, 1, 2, 3, and 2, 2, 1, 7, those are not multiples of each other. So you've got 2 different vectors in R4. And together, those would form a 2-dimensional subspace. But we can't always just look at them and tell immediately what those subspaces are going to be. So what we're going to do is we're going to look at row space and column space individually, and we're going to look at methods for finding bases of the column space and of the row space. So we'll do that in the next video.